Day 262 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 427, construct quad tree. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. So let's get into it, y'all. But before we get started, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, check out that link in the description. Now let's see what the question says, y'all. Question says, given an n by n matrix grid of zeros and ones only, we want to represent grid with a quad tree. Return the root of the quad tree representing grid. A quad tree is a tree data structure in which each internal node has exactly 4 children. Besides, each node has 2 attributes. Val is true if the node represents a grid of ones, or false if the node represents a grid of zeros. Notice that you can assign the val to true or false when isLeaf is false, and both are accepted in the answer. IsLeaf is true if the node is a leaf node on the tree, or false if the node has 4 children. So then they give us what the node class is. So the node is going to have a boolean, a value. It's going to have a value, which will be a boolean. Its leaf is a boolean. Then it's going to have a top left node, a top right node, a bottom left node, and a bottom right node. And it says we can construct a quad tree from a 2-dimensional area using the following steps. If the current grid has the same value, i.e. all ones or all zeros, set isLeaf to true and set val to the value of the grid and set the 4 children to null and stop. If the current grid has different values, set isLeaf to false and set the value to any value and divide the current grid into 4 subgrids as shown in the photo. Recurse for each of the children with the proper subgrid. Then it says if you want to know more about a quad tree, you can return to the Wikipedia page, and we don't really need to go over this section for solving the problem. So let's get into it. Let's look at example 1, y'all. So in example 1, we have this grid right here, right? We have the input grid equals a grid, first row 0, 1, second row is 1, 0. The output is a quad tree with the root being 0, 1, then the leaf nodes being 1, 0, 1, 1, 1, 1, and 1, 0. Explanation says the explanation of this example is shown below. Notice that 0 represents false and 1 represents true in the photo representing the quad tree. So let's look at this photo so we can really break it down. So as you can see, we have this grid right here. Boom. So it's represented right here with some nice colors. So let's look at this grid right here, right? So as you can see, we have the grid. Now this whole grid, that's just going to represent the root node, right? And we're just going to start that off with 0, 1, just like this. Now, each one of these quadrants, you see we had to separate this grid into 4 separate quadrants so that every quadrant only is basically the same number. But since it's only one number in this quadrant, it's just separated into 4 quadrants. I'll tell you what I mean by when we get to example 2. But we separate this into 4 quadrants, right? And each quadrant is going to represent a different leaf node for the overall root, which would be the grid. So as you can see, this top left quadrant is a 0, but it's a leaf node. So we're going to set isLeaf to 1, and it has a value of 0, so it's a 0. And remember, isLeaf setting to 1, that just means that's the same thing as saying isLeaf is true. So boom. Then we do the top right. It has a value of 1, and it's a leaf node. So it's a leaf node because we didn't have to break it down any further. I'll show you what I mean by that in example 2. But this is a leaf node and it has a value of 1. So boom, we give it a value of 1 right here. Then we come to the bottom left. It's a leaf node and it has a value of 1. So we come right here, leaf node, value of 1. Boom. Then we come to the bottom right. It's a leaf node as well, and it has a value of 0. So we come over here and add that node, and it's a leaf node value of 1, and it has a value of 0. Remember, the quad tree is always going to have 4 children. So these are the 4 children nodes right here. The top left, bottom right, bottom left, and bottom right. And that's how we created our quad tree based on each quadrant in the grid. So now let's look at example 2 where the grid is a little bit bigger and they may try to throw a little trick our way where we might have to separate or break a quadrant down even further than we did in example 1. So I'm not going to go through the input and the output of this example. We're going to go straight to the explanation. Explanation says all values in the grid are not the same. We divide the grid into 4 subgrids. The top left, and bottom right each has the same value. The top right have different values, so we divide it into 4 subgrids where each has the same value. Explanation is shown in the picture below. So now we have this bigger grid, right? So once again, we'll just let this bigger grid represent the root node, right? And so we just start that off with 0 and 1, just like this. Boom. Now let's get into these children nodes. So we already separated into 4 quadrants. Now remember, we separate the quadrants by all values having the same number, right? So in the top left quadrant, it's all ones. Bottom left quadrant, it's all ones. Bottom right quadrant, it's all zeros. But as you can see in the top right quadrant right here, it's not all of the same numbers. So what that lets us know is we need to break it down to even smaller quadrants until we have all the same numbers in the same quadrant, right? So as you can see in our sub quadrant of the top right quadrant, our top right sub quadrant, all zeros. Top left sub quadrant is all zeros. Top right sub quadrant is all zeros. Bottom left sub quadrant is all ones, and bottom right sub quadrant is all ones as well. So now let's break this grid down and turn it into a quad tree, right? So remember, the root is just the whole grid, so we just put the root right here. Then this is a leaf right here. We know it's a leaf. Top left is a leaf because we know it's a leaf because all the numbers are the same. We don't have to split it up into any more quadrants, so we know that that's a leaf quadrant. So we set is leaf to 1 for true, and it has a value of all ones, so we put a value of 1 and we put is leaf 1. Now we come over to the top right quadrant. As we can see in the top right quadrant, we have to break it down to smaller quadrants so that we can have all numbers in the same, or all of the same numbers in each quadrant. So that is why when we come right here to the top right quadrant, its leaf is set to 0 because we know it's not a leaf because we had to break it down even further. So the fact that we had to break it down even further in the sub quadrants, that lets us know that it's not a leaf. So then we come down here, and now so the top right has children nodes, and it's a quad tree, so it has to have 4 children nodes, which is why we broke it up into 4 quadrants. So the top right is leaf. That's false because it's not a leaf. These are the leaves of the top right? So we come down here. This top left is the top left of the sub quadrant, representing this right here. It has a value of 0 because it's all zeros, and we set is leaf to true or 1 because we don't have to break it down any further. Same thing with top right is leaf, set that to 1 because we don't have to break it down any further, 1 for true, and it has a value of all zeros, so we put the value of 0. Bottom left sub quadrant is a leaf because we don't have to break it down any further, and it has a value of all ones, so we put is leaf 1, value 1. Then same thing, bottom right sub quadrant, we know it's a leaf node because we don't have to break it down any further because it has all of the same values in its quadrant, which is a value of 1, so we can put a value of 1 and set is leaf to 1. Now this is the only quadrant, the top right is the only quadrant that is not a leaf node. Bottom left is a leaf node, so we keep going down. Bottom left is a leaf node because it has all ones, so we don't have to break it down any further. And same from bottom right, it's a leaf node because it's all zeros, and we don't have to break it down any further. We had to break the top right down further because the top right was not all of the same numbers. If it was, then we wouldn't have to break it down any further. But since it wasn't, we had to keep breaking it down into quadrants until we get quadrants, till each quadrant has all of the same numbers, and that's what we did right here in the top right. And that's a picture right here of how we did it, right? So this is the top right, representing that it's not a leaf node, and these are the top right quadrants right here, representing the leaf nodes of the top right quadrants once we broke it down one step further. So Now that we understand the question, y'all, let's get into the fun part, the actual solution. And trust me, the solution is not as difficult as the question. So let's get into it. So we're going to use some recursion here. So the first thing we're going to do is we're going to define our recursion function. We're just going to say func. We could call it DFS, open up the parentheses, say underscore n colon. It's going to be an integer, comma. Then we'll say underscore row colon. That's going to be an integer as well, comma, underscore col for column. That's going to be colon. Then we're, excuse me, underscore col for column, but then we're going to put a colon. Col doesn't stand for colon. But how it go? Either way, let's keep moving. That's going to be an integer as well. Then we're going to come like this, and it's going to return a node. Boom. Open up the brackets. Now let's get started. First thing we need to do is we need a variable to check if all values in the current grid are the same. So we're just going to declare a variable, and we're going to say all same, and we'll set that equal to true just to start. Boom. Now we need to iterate through the current grid of section of n by n. So in order to do that, we're going to say for I n 0 up to n. So for I n 0 dot less than n, open up the brackets. And now we're going to check to see if any value is different from the top left value to of the section, or the section is not in uniform, right? So in order to do that, we're going to say if grid square bracket row, come outside that square bracket, open up more square brackets, call exclamation point equal, which means does not equal grid square bracket row, come outside that square bracket, call plus j. We're going to come outside of that, and we are going to say, oh, excuse me, moving too fast. So this, we still have, so first we do the for I and 0 up the end, but we still need to do the for j, excuse me, for j and 0 dot up to n. Then open up the brackets. Excuse me, y'all, and we can put a bracket down here. Sorry about that, y'all. But after that, we're going to come out here, come outside this code plus j square bracket, and we're going to open up some more brackets, and we are going to say all same. We're going to set that equal to false, and we're going to come down here, and we're going to say break. Boom. Now we need to see if all values in the section are the same to create a leaf node, and set the leaf node is true, and set the val based on the grid value. So we're going to do that, we're just going to come down here. Excuse me, y'all, let me clean this up a little bit. So we're going to come right here outside of the for loop. We're going to say if all same, open up the brackets, then we could return node, open up the parentheses, grid, square bracket row, come outside that square bracket call, come outside that square bracket, equals 1, comma, true. Boom. Now we need to see if the section is not uniform, then we need to divide it into 4 quadrants and process each quadrant recursively. So in order to do that, we're going to come outside of this if statement, and we are going to declare a variable called n, and we're going to set that equal to n divided by 2. Then we're going to declare, so this is just going to cut the grid size in half and section it up for each quadrant. Now we need to recursively go through the top left quadrant. So in order to do that, we're going to say var top left equals DFS, open up the parentheses, n, comma, row, comma, call. Boom. Then we need to do the same thing for top right. So we're going to say top, top right is going to equal DFS, open up the parentheses, n, comma, row, comma, call, plus n. Boom. Then we need to do the same thing for the bottom left. So we're going to say var bottom left equals DFS, open up the parentheses, n, comma, row, row, n, comma, row, plus n, comma, call. Then we need to do the bottom right quadrant. So in order to do that, we're going to say going to declare a variable, call it bottom right. We're going to set that equal to DFS, open up the parentheses, n, comma, row, plus n, comma, call, plus n. Just like that. And now we need to create our internal node to combine the 4 quadrants. So in order to do that, we are just going to come down here and we are going to declare a variable called result node. Set that equal to a node, open up the parentheses, false, comma, false. Come underneath that, we're going to say result node dot top left equals top left. Then we're going to say result node dot top right equals top right. Then result node dot bottom left equals bottom left, and result node dot bottom right equals bottom right, just like that. Then we need to return the result node. So in order to do that, we just come down here, we say return result node. Boom. And now it's time to start building the quad tree from the entire grid, beginning from the top left corner. So to do that, we just come down here and we call return DFS, open up the parentheses, grid dot count, comma, 0, comma, 0. Now let's run it. That should be all she wrote, y'all. Hopefully it works. First try. Let's see. Oh, we got the wrong answer. So the question is, where did we go wrong? 9 times out of 10, when you get the wrong answer, that means somewhere along the line, the math is probably not mathing. Math probably got messed up somewhere. So let's see what we can figure out. See if we can figure out where we went wrong. Let's see, y'all. Let's see. My bad, y'all. Let's see. So they got the wrong answer. Let me see. Oh, so here we go. This should be row plus I, y'all. Sorry about that. So let's run it again. See how it runs this time. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted. Let's see. Ooh, look at that, y'all. 18 milliseconds beats 95% of users with Swift, y'all. Them some good numbers right there. Those are the numbers we want to see. So I hope y'all learned something today. Before we leave, though, get one more look at the code. Y'all. Read it, learn it, love it, internalize it, do what you got to do with it. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.